Hello, I'm Jamie Bowen. I work for Forge Rock on Queen's Square. Just promote Forge Rock, just talk about the identity of things and the Internet of Things. So, first of all, there's a lot of hype and media heat right now about the Internet of Things. So I should qualify what it is that I'm talking about, as it's branching off into many different fields. So first I'll cover what I'm going to be talking about and qualify what I believe to be the Internet of Things, which is essentially sensors and controllers connected to the Internet rather than our phones and tablets. So the numbers are staggering, which is why I think there's quite so much media interest around the Internet of Things. Forrester, or maybe I think it was Gartner figures these ones, 26 billion units will be connected to the Internet, providing us with data from things by 2020. And that will produce incremental revenue per year of more than $300 billion. So you can see why people are getting quite excited about the Internet of Things. So where does the Internet of Things come from? It's come from changes in product design that we've seen over the last 10 years, I would say. And products are getting not just smarter, but ever more connected. And they're having more and more of an integrated aspect in our lives. So design has gone from pure products once upon a time to smart products, which meant that they sort of analyse the data they produce, and then to smart connected products, which is a bit intangible. So I'll tell you a story. I'm quite a keen mountain biker and used to mountain bike a lot in the Quantox down in Taunton, near Taunton where I used to work. And we used to get around the Quantox with a device like this, and it was fantastic. We were all absolutely made up because it helped us find loads of new paths around the Quantox, and it recorded where we went, but we had to connect it to a PC, we had to install software on the PC. It didn't have any connectivity outside and of itself, but it was amazing for what it did. And nowadays we end up with apps like this on the App Store running on our phones, which will connect with wearables like iWatches, and they'll connect with heart rate monitors. They'll record all of our data, analyze it, show us where we've been on maps because it's connected to the Internet, so we can get information from the Internet. And it will also allow us to socialize and share the data that have been produced by our bodies ultimately, sensed by the sensors that we're wearing and the sensors built into the phone, and you can brag about how quickly you managed to scoot around the Quantox on Facebook or Twitter to your heart's content. So that's how they've got more connected and ever smarter. So why now? Why has the Internet of Things happened now? Why has it happened over the last 10 years? And it's kind of a perfect storm of technologies that's changed the way things have worked. Largely driven by mobiles and our mobile phones, which has driven a massive connectivity drive. There's more bandwidth and GPR, broadband data. There's GPRS networks now that are connecting ever faster, and the bandwidth available to our connected devices is huge. We also have miniaturization aspects, so the use of mobile phones and the ever-presence and ever-improvement of mobile phones has meant that there are Wi-Fi sensors and GPRS sensors that are smaller and lower powered, which means that we can actually put tiny stuff into a very small sensor that doesn't use a massive amount of power, and that drives the Internet of Things. We also have IPv6, so we can actually now put loads and loads and loads of things on the Internet rather than just loads of things. And we have an API economy, which has also helped small devices have things to talk to and send their data to. So we understand how to build APIs in the cloud now. So all of those things mean that we'll see the Internet of Things moving outside of our own personal lives and my little GPS. Sorry, I'm going to get GPS and GPRS confused throughout the whole rest of the talk. So if I say one, I mean the other. You'll have to work that out. So my little GPS sensor is very personal to me, and the data it produced was very personal. But this perfect storm has driven the price and ability to build sensors into lots and lots of other verticals. So out of just consumer and into the industrial world and smart cities. And we're seeing uses for the Internet of Things in health and medical, infrastructure management. Smart cities are really big. Transport management of smart cities and adaptive parking. We're seeing smart routing of traffic in big cities, down to smart lighting in San Francisco and Los Angeles. It's going to be big in manufacturing, where we have existing control systems that are working at the factory level. They can easily be adapted to use more modern and cheap consumer technology rather than bespoke wire-based control systems. So smart and home and personal devices is just the tip of the iceberg, really. We're going to see many, many, many more sensors come online. So we've been working with a few different ecosystems in the Internet of Things world, and we see a common pattern. And very often we'll see data coming from things, be they in the home or be them in a smart city, and they'll be talking a thing-specific protocol, which are very lightweight, very easy on power and bandwidth. And those are things like CoAP and MQTT, message-driven, event-driven, lightweight transports. And often they will talk to a central hub, although there's no need for them to. They will by organisation, which will act as a gateway and a boundary between the things world and the sort of messaging world to the internet world and HTTP. So that's why we're seeing here the sort of gateway access between your phone or a router, or in the Internet of Things, maybe a great big server somewhere. And that will bridge data into the cloud, which is obviously in the internet world, and then enterprise will have access to that data and be able to do lots of clever Elasticsearch and big data analysis. So, I haven't talked much about identity. I've talked to explain what I mean by the Internet of Things. So, what do we mean by identity in relation to the Internet of Things? Well, I would postulate that identity is the key to both security and monetization of the Internet of Things. And to demonstrate this, I'm going to tell another story about a little project we did with ARM. And oh, I forgot these bits. So yes, so we need to bring identity to the Internet of Things on two fronts. So we need to manage the identity of things and the sensors and the data that they produce, so that we're sure that the things that are telling us about the world around us are the things that we think they are. It gets really abstract talking about things. And we need to understand the identity of the people that are going to interact with sensors and control the physical devices in the Internet of Things around us and the data that we produce. So I'm going to show you a very short video, I think it's 2 minutes or something, because it introduces the project that we did with ARM, probably quicker than I could waffle about.
I'm Michael Koster, and I'm here at ARM TechCon to show you the demo we have of a connected coffee machine. And on the machine, the scenario is that a customer will have a connected Nespresso machine, and the Nespresso or some other service will be able to track the customer's use of coffee and provide services such as automatically ordering refills of coffee capsules when needed. So what we've done here is connected a color sensor to the coffee machine. We've created a 3D printed harness that you can connect the color sensor to using an LED and a photo transistor. And it senses the color of the capsule, and what we have is using Embed device server and Embed OS, an implementation of this application. So the color sensor is connected to an Embed OS running microcontroller that registers itself with Embed device server. Then the application we call Barista connects to the device server, and it gets notifications every time the capsules change.
So just stop it there very quickly. The device, the MCU down here on the Nespresso machine, that's a tiny little board which just has a microcontroller in, And the Embed device server that he talked about there is acting as a gateway. So that's receiving the co-app messages from the devices and acting as the bridge into the HTTP world, where they have a Barista app, which is essentially just a web app that's talking to the back end. It's making REST requests to the Embed device server to get data, register for updates of information.
And then there's a web browser. We're showing you here the website that shows some statistics about the coffee use and then the current capsule that's being brewed. And that was the original application. Then using Embed device server and Embed OS, we added a second application onto that, which changes the LED color in the booth. And so there's 2 more microcontrollers running Embed OS, controlling LED strips. They've also registered with Embed device server in the cloud, and then we're running a little Python script. The Python script reads the capsule type from the feed to the website, to the web browser. It looks up the color of the capsule and tries to reproduce it by changing the color of the LEDs. So I'll show you how it all works. We'll brew a cup of coffee here. So I'll pick a capsule. What do I want? I want to drink Levanto. So it's a sort of a gold colored capsule, and we'll put the capsule in the machine. You see it's detected Levanto. The LEDs in front have changed to indicate an orange capsule has been put in. And then we can brew the coffee, and all of this is made possible.
I think we get the point. So he's made a coffee, and a number has gone up by 1, and he's changed an LED. So that's all really good. There's the web app, and that's what we started talking to Arm, is how can we actually enrich this data, and how can we bring identity to this demonstration? So there's a picture that's probably way too small to see on your monitors, but really it's showing another view of the picture I showed in the architecture. So we have devices down here as well, over here look exactly the same, and they're all talking message, low bandwidth, low power messages to the local broker, which is the Embed server, and then we're putting a protection layer in there which will do API protection, and it will do identity management using OAuth 2 and OpenID Connect. So it's just kind of a standard web access management layer in there. And then the web service that Arm built, we're sort of replacing that with identity enabled, much better. So this was our first screen. Once you start putting identity in there, we could know who had the Bluetooth tag. He didn't mention that in his demo, actually, so the key point of that whole system was that people were issued with Bluetooth low-frequency beacons. And when they went up to get a coffee, the machine would also detect who was closest to the machine, and it would notch up the numbers. But they didn't do anything with that because they didn't know how to handle the identity. So we set up a system where people could self-register, and they could log in, provide a username and password, and the ID of the Bluetooth tag they had. So when they went up to get a coffee from the machine, we knew the identity of the machine, because we pre-registered that in our system, and we knew the identity of the people that were getting a coffee. So here we see Alan Foster has enjoyed an arpeggio from the conference hall machine, and all of a sudden you can socialise that event and provide them with a feed. So everything can be socialised in the Internet of Things. More interestingly, I suppose, we can also show Alan his coffee drinking habits. We can show how many coffees he's had in the last 30 days, how many in the last 7, and how many in the last 24 hours. We can probably gauge from that when Alan was getting stressed and needed to stay up late and get a presentation about the Internet of Things together. And moving back up the sort of food chain, because the coffee machine itself is also registered as an identity in our system. As it's registered in our system, we can look at the individual data on a coffee machine by coffee machine basis. So the coffee shop owner or a hotel owner can see which coffee machines are doing best at what times, which capsules are drunk where, and know a lot more and learn a lot more about his population of customers and the coffee drinking habits. So I'm sure you'll agree that adds lots and lots of information and value to the data that we're generating from the Internet of Things. So what is identity? We've done identity, we've done what is the Internet of Things, and I've explained why identity is a great thing to add to the Internet of Things, but I haven't really talked about what identity is. So identity of sensors and the data they produce is really important. In this instance, how do we know that the coffee machine that's producing data actually is that coffee machine, rather than someone sending a curl command to a website or generating a COAP packet that pretends to be that machine? And also, how do we know that the people that are going up are the people that are going in? So identity used to be paper-based, issued identities that were issued by an authority that we trusted. And these days, and the identity of things were again unique serial numbers and unique identifiers that we would stick onto our things, our products. So to identify people, we now have 3 factors of identification, and how many you want to use depends on how secure you need the authentication to be, how much we need to trust that a person really is a person. So there are 3 factors that we can use, and first is something that you know, which is the ubiquitous username and password. If I know my password, it must be me. The second factor is something that you have, and this is where there are quite a lot of new products recently around this area, where YubiKey and FIDO Alliance are producing small dongles like this one that you can see, where you can use 2-factor authentication to protect your Gmail account. So you have to set up Gmail to recognize it and register it, but Gmail will send you a request for a one-time password, and all you have to do is put your finger on this shiny panel on the key, and a 2-factor auth will be sent to Google, and it knows that you not only know something, your username and password, but you have something. You have a key that it knows that you should have. And the third factor is something that you are. So it's a fingerprint or an eyeball scanner, or I didn't get my props out. There's a really, really interesting and very secure piece that we have, which is, I'm going to pull something I don't want to pull out there. So anyway, there's a very interesting device called a NIMI band now, which just goes around your wrist and has a contact sensor on. I pop it around my wrist, touch my finger on it, and it will take an ECG of my heart and use that to authenticate with an app on my phone or my laptop, which has seen my heart before, and say, oh yes, I recognise this heart, must be me. And then provision an ID to that NIMI band, and I can then use that. As long as I've got it on my wrist and I don't break the connection, it knows that it's me, and that's a heart, being used to prove that I am me. So when it comes to devices, it's a bit trickier because devices can't type usernames and passwords. So we have the sort of age-old digital certificate method, which is what you see when you click on the browser and you want to look at the information when you're connected to an HTTPS website. If you click on the lock, you can see all the information about a digital certificate, and it's perfectly possible to put a digital certificate onto a device. The problem there being, how do you know that someone hasn't then removed that digital certificate and put one of their own on there? And that's where this picture of this very tiny red thing up in the top corner comes in. And that's a secure element which is configured to either have a certificate on from the factory, or you can push a certificate to it one time only. It has sort of a once-write memory model. And that way we can provision a certificate to our thing and know when it connects to our gateway server that it is a thing. And that way we can also secure communication, so we can use DTLS, which is the datagram version, because our things often go UDP packets rather than TCP/IP. So we can then use the equivalent in the datagram world of HTTPS and a secure connection. And our mobiles already have a very similar thing, and they have SIM cards which are extremely secure. Thank you very much. I may not need that one. I'm rapping through these. So, once we have all those things, we need to then try to apply them to our system. So what we did is we registered, we allowed the users to register their identities and provide a username and password and their details into what is an identity repository, which is really just akin to a yellow pages or a directory. So other systems can use that directory to find out who something is. Usernames and passwords can all be stored in it, and information about addresses and anything else that we want to understand. In the case of the coffee machine, we stored the Bluetooth ID of the Bluetooth beacon that each person was issued. So we could do a lookup into that directory and say, we've got a Bluetooth ID, where's the user associated with this, and hopefully just one will come back. We also then need to build some policy around our identities. So we have a rules-based engine which can say if the resource is a coffee machine in the grand hall, then X people can use it if they're in a certain organisation, and if they're not in that organisation, maybe they can't use it because it's getting billed back to one organisation. So we can build all sorts of clever and funky rules based on attributes of the things, so maybe the location of the device, or attributes to do with the people, so maybe the department that they belong in. And then we need to build a layer of protection around that, which we did using a kind of reverse proxy, which would intercept the web requests that went to the barista app, or the bridge layer, the embed server, and based on whether people were authenticated or not, then we would allow them in or not. And once we've allowed them in, we would know who they are and can present them with just their own data. So that's why Alan only saw Alan's coffee events and he didn't see my coffee events. And that's the access management piece. So, so I tried to find some examples of how not to do identity and why identity and security around identity matters in the Internet of Things. And I have a friend who works in Bath, who's not one of you two, I hasten to add, who works for Love Honey, and they're very interested in the Internet of Things. Love Honey make, I can't think what their tagline is, but they make love toys. And they're very interested in the Internet of Things and enabling remote use of sexual toys. So, the point I'm trying to make here is that secret links are not always secret. I mean, anyone who's used Google Docs know that it's very hard to maintain the privacy of a Google Doc, right? And if you get the settings wrong, anyone with a link can view your data. So I managed to find this on the internet, Oh My Bod, which is an application that you can get for your iPhone that will use, it will control a vibrator over the internet, and it uses Google Hangouts. So that is how not to connect. Do you really trust that link not to get shared when you're letting something that intimate into your life? So with that, I thank you all for listening, and I hope you all learned something. Maybe not that last bit. So I think I finished a bit early, have I? All the more time for questions. Does anyone have any questions?
So, I have a question.
Good, good.
You talk about policies and access management stuff. I'm kind of trying to understand, because the Internet thing is quite a complicated topic. It's quite big, there's lots of different uses. So when you're more talking about access control lists and kind of more like kind of saying you can do this or you can't do that depending on which resource that you're talking to. So for example, I think the closest thing I could think of in the parallel to that would be AWS's IMA policy system for their resources. Is that the kind of approach? I'm trying to think of something that is lots of things
Right.
that you want to control centrally, of a thing that people may understand, something that relates
Well,
to.
I'm very glad you asked that question, because we've been that's actually one of the biggest aspects that we've been struggling with. So we're great at protecting static, well-known resources. We've been doing it for years. And as an industry of access control management, we're sort of used to protecting resources that don't come and go. They're there, so maybe it's like web URLs or web resources is a typical thing that someone will want to build a policy around and protect. But in this scenario, it's much trickier because we don't have kind of a schema for things. We have schemas for users. We know, all the things that typically represent users. So typically directories already come with a schema that allows you to represent users and store users. So we have to have a very flexible schema model because we don't know what attributes or what resources a thing will come with, what sensors it will have on it, what data it produces, which presents problems. When you don't know what a thing looks like, you also have to be a lot more flexible about how you build protection around it, about how you build your policies. So yes, that's a real issue. And we've been looking at moving away from directories to model policies, which are generally static. You say, if the URL has, a pattern match, and you can put some regex thing together to match your URL, and the person's in this group, then they can't access it. But that's too static. We don't know what's going to come along. So we've been looking at using graph databases to model the things, the devices, and their attributes, and then you can build really flexible queries into that, and that allows us to move to something. Often we've done role-based, so what I described earlier was role-based access control, whereas if a person's in this group, they can't access that thing. So we need to move even more urgently with the Internet of Things. We need to move to an attribute-based access control, which is where I touched on, where I said you can build rules around if a user has some attributes and the thing has some attributes. And at real time, you need to be able to get a thing back schemaless, kind of like a document database that understands JSON. If a thing can be modeled in JSON, you can pull it back and you can do some queries on whether it has an attribute. Does it have this attribute? If it does, is it this value? Yes, it matches. So then we can do attribute-based, and then you can build rules preemptively before you know what's coming onto as long as you know roughly the resources that are coming on. You can say if this is a heart rate monitor. Oh, well, a typical scenario that we've been working with is with light bulbs. So Arm have deployed smart light bulbs across Los Angeles, and they all have an idea of their location and whether they're working or not. And they also know, they can also receive commands to turn off and on. So there's one set of people that we want to say, yes, you can see when they're broken from your phone app in your car, because you might want to go around and replace it. You've got the appropriate ladder and bulbs in the back, and quite another person in a different department that might want to go and turn it on. But we don't want to have to know the identity of that bulb beforehand. We don't want to have to know the URLs, but you can protect it in a much easier way. So you can say, if this is a control, we don't want this group to be able to do post commands to any devices, whereas this one's over here, yes, they can do post commands. So based on the attributes of the thing and the people. So it's actually it's quite an emerging field, that, and there's no consensus or really industry agreement around that. But it's a really interesting topic, and one where I think people can differentiate in the moment. What a brilliant question. Any more questions?
I've got another one.
Well, come on.
Yeah, go that way.
I think it's a really interesting topic about how the physical world can be compromised, but it's essentially by the digital world. I mean, it's quite a funny example you said about the sex toy. I think it's quite a good one. What would you say a good example is then of how the Internet of Things has been used well in my if any?
I don't think there's... Okay, I'm loath to have to say this, but I suppose you pushed me into that corner. I think some of the apps that come with existing identity ecosystems are pretty well protected. So maybe the Apple HomeKit and things like that, where Apple knows your identity and they're pretty good at holding identities. So I think, for me, I think the home automation bit will probably be owned by people that already own our identities. So Android and Apple will already have a step up there. So I think Samsung coming along and saying, we're going to come out with a thing that's going to control everything in your home is maybe, although they're very strong in the Android ecosystem, it's kind of Google that's got the identities. So I think it's going to be difficult for anyone to come along and take that. Actually, the control, because it is all around identity, and that's what's really important for securing these things. The identity gatherers, maybe even Salesforce and people like that, are in a really good, strong position and have quite a good story so far. I hope that answers your question.
Thanks.
Should we start at the back, front? Not the microphone. Work back. I think your hand went up first. Let's start at the back and work forward.
What role do you think standardisation has to play in all of this? Both from an authentication and an authorisation perspective. So we've got PKI, which is certificates, which is basically it for things, but then for people we don't really have a standard, and for authorisation we really don't have a standard. So do you think we need one? Do you think it's good to have one?
There are standards in authorization, so we have SAML and OpenID Connect and OAuth, and there are things like that, but not all of them are completely suitable for the Internet of Things. OAuth is very good at letting me share my data with another app that I'm using, but it's less good at letting me share data with any one of you and then taking it away later. And there are emerging standards, one of them being UMA, which is supposed to be very good at that and tackles that particular use case. But around the PKI, I don't know. I mean, it's going to be difficult. I think it depends very much on the vertical that we're looking at. In a smart city, I can see that actually a city would want to provision their own certificates on things and trust their own certificates, and they'll be their own source of trust. Whereas all of us, it's difficult when we want to interact with things that have been produced by small consumers. How do we trust? It's exactly the same issue of how do we know to trust a website at the moment, and that's difficult enough. But when it becomes something really critical, like a heart rate monitor or some physical kit that's got data really, that could change your insurance policies or driving policies, then it's, the pessimist in me says, oh, well, people will just do it anyway, because that's what we do with websites, right? We just, go, that's fine, I'm sure the trust stores are fine and there's no one dodgy in my browser-based trust store, but there really are. So I don't know. I think we'll have to wait and see. It's too early for standards. I think there'll be a lot of companies going in a lot of different directions, and it'll be market pressure that probably drives us to a standard rather than an organisational push, probably. But I'm no guru on that side of things. So there was someone in that row, and then forward.
So very interesting talk and a very, very important topic.
Thank you, sir.
So one question is about how you actually simplify this stuff, that somebody who is the manufacturer of sex toys or dolls or kettles can actually use.
Sex kettles.
Whatever. At the moment, to make anything halfway secure, you need to be far too much of an expert,
Yeah.
even if you can achieve it as an expert. So do you have any views about how this will get simplified, encapsulated to the point that when I make an intelligent Hoover or something, actually it's got the right sort of security?
Yeah, I personally, I think we'll see more of a shift to identity as a service and protection as a service, where these ARM are making a big play with that, trying to create an ecosystem where they're a cloud-based service. If you buy the Embed board and you base your device on the Embed chip, maybe you can put an Embed OS on and everything's Embed and everything works quite nicely. So I guess there'll be little islands of services that we can buy or that we can use as a device manufacturer that will give us maybe more safety than if we did it ourselves. But I guess there's no absolutes, and I guess there'll be, when there's errors with those, it could be whole swaths of devices and services that are compromised. So I still wouldn't trust my sex toys to the internet.
Around the hardware you were saying with the coffee machine, I think, if I didn't misunderstand, you said that you had some embedded electronics talking to different embedded electronics, which then spoke to the internet. So kind of two layers. I haven't really seen that before. I've normally seen kind of a hardware unit or Raspberry Pi just directly connecting from the thing to the internet.
Right.
Can you talk a little bit more about
Yeah,
that?
okay. Yeah, that's interesting. Yeah, so that's with the Embed device server, which is, I guess this is a little bit specific to the ARM ecosystem, but we're seeing very often in these gateway devices that act between the co-app world and the internet world, there is a notion of callbacks. So the internet isn't really set up for server to client communication, although it's getting more so with things like WebSockets. But if you've got lots of data coming out of your things and they hit this sort of bridge layer, you want to know what's happening on your devices. You have to register for callbacks, and they'll come through WebSockets or via some other mechanism. You can provide a push URL, which is great if your server happens to be, on the internet and out in the big wide world. Otherwise, it's WebSockets, and you as a client connect to the gateway, and the gateway will push notifications of events that you've registered for. It's a whole other security issue. How do you know that the people you're pushing notifications for are allowed to see the data that's coming back? But that's what was happening there. So they built a thing on an Embed board that was pushing data to the Embed server. They had something else that was registered for notifications from the Embed server. And when it got notifications that a coffee capsule had been popped in and someone was making a drink, it would receive that.
That's
and
the
then
thing that interested me. Why aren't the Embed boards equivalent to the Embed server, considering that the devices are so cheap nowadays? Why do you need two layers there?
Why aren't the Embed boards equivalent to the Embed server? Actually, they are. So what's happening, because the co-app server is very lightweight, in order to communicate, you have to have a co-app server and a client on each end. So there are co-app servers and co-app clients running on both the Embed server and the Embed OS on the device. But really, it's just a mechanism. The fact that the Embed server is a server is just nominal. It's in the same way that when you use GitHub, you have to have a master repository somewhere that people can push to and sync to. And really, it's only by convention that the Embed server is deemed to be the server. But also, there's a bit more built on underneath that. There's a device registration or registry. So when the devices start up, they'll register all of their resources with the server, and it's the server that then makes them available to the internet, to the rest world. That answers your question. Save the best till last, no doubt.
In the consumer world, there's a bit of a thing going on with if you have a light bulb and a kettle and all these different kind of consumer devices.
Yeah.
There's no one channel that they're going down. So if you want to control your light bulb, you generally get out your light bulb app, and you want to control the kettle,
Yeah.
the kettle app.
Yeah.
And you touched on standards and this sort of thing. The Google I/O recently, Google talked about Brillo and Weave. Do you really see that having legs? Do you see developers actually wanting to integrate that, or do you just see it as another way of Google data and it's going to collapse?
I think the latter. I don't know. I'm ever hopeful of standards, but I don't think the Apple world and the Android world will ever really touch. Although maybe Android, maybe Google will be clever enough. So I don't know. This is a very new announcement last week. So Google have stripped down Android and taken the nice shiny front end off it and produced a little OS that they want to be the operating system for the Internet of Things. And it seems mostly home-based, I think, to be fair. So it's kind of a play with and they work with Nest, which they bought, which produce all the home thermostats and devices, and have come up with not standard, but an ecosystem called Weave, where you describe an interface effectively to your device. So if you've got a door lock, you can say unlock and lock, and then the idea is that I think when you build within an ecosystem, so you know your phone app has to know that locks can be locked and unlocked, but then there's a registry or like a central registry where you can find things that are locks in your house and control them. And so I think the short answer, I think we're going to end up with how many remote controls do you have in your lounge?
About 4.
Right. I think you're going to end up with probably as many apps on your phone to control the things, maybe more. I think that's the reality of it, because people will go their own way. Some people will use the Google way, and then maybe if you've got the Apple kit, you know, you'll end up with maybe 2 phones. Who knows? It's not going to be good for a while. It's going to be a right old mess. Anyone else? Oh.
Is there any, well, it's short, it's kind of, I could talk on this short question. Is there any hope of us controlling our own identity? Because you talked about people, you know, the various companies who think they own your identity.
Right.
Phone company, Google, Apple, whoever. And then you can associate devices. And that's probably the simple part, to be honest. But in terms of the human side, what is our identity and how do we own it versus something?
That's a very interesting and quite philosophical question, I guess. So the question, did everyone hear the question? So the question was, how do we, is there any chance that we will own our own identities? And I don't think there is. I'm sad that there is, because I talked about the UMA standard, which allows us to control who can see our data, but that's allowing a third-party company that's storing our data to let us manage who can see our data on their behalf. So actually it's making their lives easier, right? And we feel in control of our data. But we don't actually have control of our data because it's not sat on a server under the stairs, like mine is. But, so I don't know. I think identity and data is too valuable to commercial companies to really have them stand up and say, have all your data and your identity back. I don't think there's any need at all to do that. So if there is, maybe it'll be through some sort of amazing invention where you can go down to the local electrical shop and walk out with a server with your own personal cloud on. And that would be great. I would love that. If we all could buy a personal cloud, and maybe phones are getting to the point where actually a phone has enough oomph and storage that it could be, coupled with a storage hat, for example, which had a load of gigabytes of RAM in it. You could store all your data about your person and carry it around with you. But short of technical innovation, I don't think there's any commercial reasons.
It seems to me that both the Internet of Things and there are kind of islands of things and identities, right?
Right.
So, you've got your Google identity and then the various things associated with that. Your Apple identity and things associated with that. There's certainly no overarching Internet of Things.
No. No, it's very difficult. And when you start to look at what is an identity, it's kind of, ironically enough, it's easier for people than it is things. I mean, I don't know if anyone remembers when Microsoft decided to have their authentic, I can't remember what it's called, genuine licensing program. Does anyone remember that? And I used to build PCs around that time, and every time you plug in a new disk, it goes, oh, I'm not the same computer anymore. Because what is the identity of a computer? Is it the CPU? Is it an amalgamation of all the things connected to it? And I think we're going to see the same thing with the identity of things. When you add, when you change something about a device or its state changes, is it the same thing? You have a kind of metaphorical question of when does something become a different entity, a different something else? And I think that's going to be trickier than people think. When you get something like a car that is going to be made up of lots of different parts that maybe all have individual identities, then how do you work out the amalgamated identity? And that's something that no one's really talking about.
I guess if a thing wants to join the club, though, it has to, define its identity.
Yeah, I guess so.
In some sense, have a choice of how to define our identity, but they're not actually. If you want to join a club, you just have to get your Apple ID and that's it.
Yeah. I mean, how do we get into meet up? Oh, another one. Yes.
Can we have one more question and then we'll have to move on.
Okay.
Scaling the identity. That's my question. Because you're talking about millions to potentially billions of devices, and that's a whole problem. Just curious what your thoughts about scaling systems to cope with the traffic.
Yeah.
We talked about graph as well.
Sorry?
We talked about graph as well, so scaling and graph.
Scaling graph is, two things that don't really sit together very well. Yeah, I think that's a huge challenge around it, and I think it would be made more urgent if everyone was going to be talking in the same ecosystem. But I think with the fragmented islands that we're going to see initially with the Internet of Things, it will all be kind of manageable. So if you've got Bristol Smart City, they've got an amazing super fast network that's going to be like a highway or a basis, the fundamental routing and traffic will all flow around on that, and there'll be some great big server sat somewhere in Bristol that's managing.
I suppose also it's a known quantity.
It's a
They
known
know how
quantity.
many things they're producing to attach to their network.
Yeah,
So therefore they know how big their network is.
exactly. Whereas if you had to manage all the identities for everything on the internet in one, then
The hypocrisy that we love, yeah.
Yeah, but there are going to be things that are going to hit scaling challenges, but it's, in theory, we can use the same technologies and strategies that we've used with the internet, by being, CoAP is very much modelled on HTTP, it's very RESTful, although it's sort of a multi-way communication. As I said, things tend to have servers and clients and talk both ways. So maybe we've got some work to do on sort of firewalls and how we work across router boundaries and things like that. But I think maybe they're more immediate pressures at the moment on the Internet of Things than the scaling. But when you look at the vast numbers, I think it's hard to get a picture. I've seen a couple of really, really good YouTube videos. There's one by a chap called Phil Windley, who does a connected car thing that's open source. He's very good, Phil Windley. And he does a really good presentation. I urge you to go and look it up. And it talks about us, trying to build out the Internet of Things using the same technology as we've built, the Internet from. And then, by example of numbers, he shows that, we're sort of sat on a mountain like this, trying to build a bridge across to this mountain that's like vast. And it's just so. I guess we're going to have to learn, go back to drawing boards and take new strategies. Phil's is by using microservices and sort of mini computers that pop up and deal with things, in a kind of isolated little island way, which is a really interesting approach. So,
Cool.
Thank you very much for listening.